Hello and welcome back to my channel. Today we're going to be talking about the arc length of a smooth planar curve and distance traveled. So arc length of a smooth planar curve. We can find the distance traveled along a path over an interval that's not a straight line. In order to do that, we are going to be using the following function or the following formula to kind of help us out. So L, which is going to be our length or arc length, is going to be equal to the integral from a to b. This is in terms of x. We are looking at a distance, so a square root is generally going to be involved. And we have 1 plus f prime of x, so our derivative squared dx. This formula has very specific reasons on why it is what it is, and we're going to use a bunch of different theorems in order to prove that, but because of what we need it for, we're going to do none of that, and we're just going to know that this is the equation we need. If you want to look more into why it is what it is, please do so. So in terms of y, the only thing that's going to be different are bounds in terms of y instead of in terms of x, but we still have that 1 plus the derivative of y this time squared dy. So they're pretty similar, but this is what it is. So our first example, find the arc length of the curve defined by the function x squared on the interval from 1 to 4. So some things that we want to keep in mind, we want f prime. So if they give us f of x, one of the first things that we may want to do is find the derivative. So we have f prime of x is equal to 2x. And now we are going to find the arc length. So our arc length, L equals the integral from 1 to 4 of the square root of 1 plus the derivative squared. So our derivative in this case is 2x, so we're going to have 2x squared. Okay. With this problem here, if I were to try to solve it, we're going to run into some weird issues. We can't really use u substitution here because we don't have an x in here somewhere that would give us our derivative. So we're going to use a calculator for this. If we do use our calculator to solve, we are going to get 15.339. So the big pieces here is we need to know what formula we're using. If it says arc length, then we need to use this formula. We need to find the derivative with respect to x, since it's with respect to x, and then we need to plug everything in. So it says, set up an integral that represents the length of the curve defined by the relation of f of y equals 4 times the quantity 2 minus y squared on the interval of 3/2 less than or equal to y less than or equal to 3. So the first thing they give us is f of y, so the first thing we should do is find y prime, or f of y prime. F prime of y. So the first thing we have here is we have an inside function and an outside function, so we have chain rule. So we do the outside function, that's squared, times 2. So we have 4 times 2, which is 8. Keep the inside the same. Take 1 away from the exponent, and then multiply by the derivative of the inside. Derivative of 2 goes away. Derivative of minus 1. Minus 1y is minus 1. So I know that this is negative 8 times 2 minus y. I could also multiply this out, so it is negative 16 plus y instead, but it doesn't matter. So now we are going to use our arc length formula. So we have the integral. They gave us 3/2 and 3, so those are going to be our bounds. And then we have the square root of 1 plus our derivative, negative 8, 2 minus y squared dy. This is a setup, and we don't have to solve, so we are done with that problem at that point. Find the curve which contains the point 0, 3, whose length from x equals 1 to x equals 4 is given by L equals the integral from 1 to 4 of the square root of 1 plus 16x cubed dx. Okay, so we want to figure out what f of x is. So our goal is to figure out f of x. We are given this here. So one of the first things we want to remember is that this is our arc length formula. So we have our bounds a to b. We have the square root of 1 plus f prime of x squared. So I can kind of match that up. We have a 1 plus, so I know that f prime of x squared is 16x to the 6th. So I want to square root this in order to get f prime by itself. So I want f prime of x. If I square root 16, this gives us 4, and then I need to square root x to the 6th, or think about what multiplied by itself gives me x to the 6th, which would be x cubed. So if I multiply 4 by 4, that gives me 16, x cubed times x cubed gives me x to the 6th. So I know this is f prime. Well, I want f of x. So what I want to do now is I want to take the integral of f prime of x to give us f of x. So we have the integral or antiderivative of 4x cubed. I add 1 to my exponent and then divide by it. So we get x to the 4th plus c. Okay, so we know f of x is x to the 4th plus c. Now we're going to use our point that they gave us, 0, 3, plug it in to find f of x. So 0 is x, 3 is y. So we get 3 is equal to c. So f of x is equal to x to the 4th plus 3. Suppose a bug crawls on a window pane following a path modeled by y equals x plus 2 sine of x. The bug starts crawling when x equals 0 and stops crawling when x equals 3 pi. How far has the bug traveled? So we want to know how far this bug has traveled, and he's traveling across this path. This is an arc length question because we're trying to figure out the distance of this function. So our arc length function, what it does is if we were to take this function, no matter what it looks like, in this case it could look like a sinusoidal since we have a sinusoidal here, but it would be like if it took that function and then stretched out that line so we could measure it. So we have an arc length problem here. So the first thing we want to know is that y is equal to our function x to sine of x. We want to find the derivative of that. The derivative of x is 1. The derivative of 2 sine of x is 2 cosine of x. Now we just need to find our arc length. So we start at 0 and we stop at 3 pi. And then we have our arc length formula, 1 plus the square root of 1 plus, and then we have 1 plus 2 cosine. And all of that needs to be squared. Dx. We would then plug this into a calculator or simplify and integrate. This looks like it would potentially be a calculator problem to me, so we would plug this into our integration symbol on our calculator, and we would get 17.416. So this one you have to know what it's asking for to know that's asking about arc length. Our last one here, we have let f of x equals e to the 2x. Let R be the region in the first quadrant bounded by the graph of f, the coordinate axes and the vertical line k. where k is bigger than 0. The region R is shown in the figure below. Write, but do not evaluate, an expression involving an integral that gives the perimeter of R in terms of k. So what we want to do is find the perimeter. And it says write but do not evaluate in an expression involving the integral. So we have to remind ourselves perimeter. So perimeter is that outside distance around whatever shape we're looking at. Okay. So some things that we can already see: the distance between 0, 0 and our point up here, 1, is a distance of 1. We have k up to this point. Well, that is that y value. So we know that this is e to the 2k. And the distance between 0 and this x value k is going to be whatever k is. What we need to know is this distance right here. And this distance is found by our arc length. So we have our perimeter is equal to 1 plus k plus e to the 2k plus whatever L is. So what we want to do is we want to find what that expression for L would be. So we have f of x. So we need to find f prime of x. The derivative of e to the 2k, or e to the 2x, is e to the 2x times the derivative of 2x, which in our case would be 2. So 2e to the 2x. So our perimeter is equal to 1 plus k plus e to the 2k plus our integral. We'll look at our bounds in a second, but we have our square root of 1 plus our derivative, 2e to the 2x squared dx. Okay, our bounds, our x value we start at is 0, the x value we end at is k, so we're going to go from 0 to k. So we have our integral expression for perimeter, so our perimeter is 1 plus k plus e to the 2k plus whatever this length of this integral is. And we don't have to solve it because we don't know what k is, but we can at least write the integral.